Network. I'm Amanda with August Cool Research, and today we'll explain what the Bittensor network is, how it works, some of the architecture and functional components, the algorithm used, and some of the tokenomics behind the DAO token. Bittensor is a decentralized machine learning network that operates as a peer-to-peer marketplace for artificial intelligence and computational resources. The protocol's primary objective is to commoditize machine intelligence, creating an open-source, permissionless ecosystem where contributors are compensated for providing and validating AI models. By leveraging a blockchain-based incentive structure, Bittensor aims to facilitate the collaborative development and consumption of high-quality, diversified machine intelligence. The development of Bittensor is rooted in the observation that leading-edge artificial intelligence is increasingly concentrated within a small group of large technology corporations. This concentration can lead to several industry challenges, including high barriers to entry for independent researchers and developers, reduced transparency in model operations, and the consolidation of control over powerful computational resources. Bittensor's design provides an alternative model. It establishes a framework where these resources, from computational power to trained neural network models, are contributed by a global, distributed network of participants. The network's design proposes that collective, decentralized competition, governed by transparent economic incentives, can lead to a more diverse, robust, and accessible form of machine intelligence than traditional centralized development models. The DAO token is the network's native cryptocurrency, serving as the central mechanism for rewarding contributions and governing the protocol's evolution. The Bittensor architecture is composed of interconnected components designed for parallel processing and scalable specialization, allowing the network to host a wide range of distinct AI services. The foundation of the system is the subtensor, the primary blockchain that serves as the network's ledger and coordination layer. The subtensor records all network activities, manages the staking and reward distribution processes, and ensures the auditability of contributions. While early operation involved centralized control by the founding entity, the roadmap focuses on a progression toward full decentralization, including the integration of an Ethereum virtual machine layer to support the deployment of complex, on-chain applications. Bittensor is structurally organized into a collective of specialized mini-networks known as subnets. Each subnet functions as an independent, incentivized marketplace dedicated to a specific computational or AI task. Examples of current and potential subnets include text generation, image rendering, data storage provision, financial market prediction, or specialized computational power lending. Subnets enable developers to create highly optimized models for narrow tasks without needing to build and maintain a massive general-purpose foundation model. By operating numerous marketplaces in parallel, the network can scale its overall intelligence capacity by adding new subnets, minimizing computational bottlenecks. The network is configured to support a growing number of these marketplaces. Within each subnet, two key participant roles drive the system. First, there are miners. These participants are the producers of intelligence. They contribute computational resources and host their machine learning models to generate outputs in response to validation requests. Miners receive TAO rewards proportional to the quality of the intelligence they provide, as measured by validators. And there are validators. These participants are responsible for curating the quality of the network. They secure their commitment by staking TAO tokens, initiate requests to miners for specific tasks, evaluate the quality and utility of the miners' responses using objective criteria, and submit their weighted rankings to the subtensor. Validators are rewarded for accurately identifying and supporting the most effective miners. This structure creates a continuous feedback loop. Validators curate quality, and miners compete to deliver the best quality, resulting in sustained network improvement. The core of Bittensor's operation is the UMA consensus, a custom-designed, on-chain algorithm that serves as the network's consensus mechanism. YC functions as a specialized form of proof of intelligence, designed to resolve a complex challenge. Reaching consensus on the subjective and probabilistic concept of intelligence value in a trustless environment. Unlike mechanisms that validate transactional integrity, UMA consensus validates utility. The YC process integrates game theory and economic incentives to ensure that the aggregate judgment of the validators accurately reflects the objective quality of the miner's work. The UMA consensus process operates via the following key steps. Ranking submission. Validators in a subnet periodically submit a vector of weights, effectively a scorecard, ranking the performance of all active miners within that subnet based on their observed utility and accuracy. Stake-weighted consensus determination. The YC algorithm calculates a consensus weight for each miner. This is determined using a stake-weighted median. A validator's influence on the final consensus is weighted by the amount of TO they have staked. This method ensures that validators with greater economic commitment and trust have a proportionally higher impact on the collective judgment. The clipping mechanism. To prevent manipulation, the YC algorithm incorporates a clipping mechanism. If a validator assigns a weight to a miner that significantly exceeds the consensus weight established by the majority of staked validators, that excess weight is disregarded or clipped. This mechanism minimizes the risk of collusion, as attempts by validators to unfairly inflate the scores of specific miners are economically neutralized and often penalized, making honest evaluation the optimal long-term financial strategy. By establishing rigorous parameters for evaluating subjective intelligence and penalizing deviation from the collective consensus, the UMA consensus enforces a common standard for quality across the network, driving all participants toward the most effective and agreed-upon definition of intelligence. The Tau token is fundamental to the protocol's economic security, incentive alignment, and operational utility, drawing structural parallels to established deflationary cryptocurrencies. The token's economic design is built around scarcity and predictable emission. The total supply of Tau is permanently capped at 21 million tokens. This limit is a core feature intended to promote scarcity and establish long-term value potential. The network implements periodic halving events, which occur when a specific quantity of Tau has been issued. These events automatically reduce the rate at which new Tau is minted, following a disinflationary schedule comparable to Bitcoin's. Tau is distributed via a fair launch model, meaning no tokens were pre-mined or sold in an initial coin offering. All circulating tokens have been earned by participants contributing work to the network from its inception, promoting broad, decentralized ownership. A significant evolution in the tokenomics is the introduction of dynamic Tau, also known as alpha tokens, which customize incentives at the subnet level. With DayTau, each subnet has its own unique token. Staking Tau into a specific subnet is essentially a mechanism for acquiring that subnet's alpha token and participating in its localized market. This change introduces a more market-driven incentive structure. Beyond direct rewards, the TO token provides functional utility across the network. Participants seeking to register as miners or establish new subnets are required to pay fees in Tau. These fees are often recycled, burned, or redistributed, contributing to the network's overall token management. Tau serves as the transactional currency for utilizing the intelligence outputs of the network. Users accessing AI models hosted on the subnets pay for these computational services using Tau. Tau holders are granted governance rights, allowing them to vote on proposals concerning network upgrades, parameter adjustments, and funding decisions. This distributed governance model is intended to ensure the protocol's evolution is guided by the collective consensus of its economically committed participants. In summary, the Bittensor network establishes an infrastructure where the production of machine intelligence is treated as a digital commodity. By combining a fixed supply cryptocurrency with a dynamic, game-theoretically enforced consensus mechanism, the protocol aims to create a highly scalable and market-aligned framework for developing and sharing artificial intelligence, offering a decentralized alternative to current proprietary AI models. Thanks for tuning in to our podcast. We hope you found it useful. To help us reach a wider audience, we would appreciate if you give us a like or share the link to this video. And be sure to subscribe to our channel to receive updates when we post content in the future. Thanks again, and have a good day.